Current enterprise AI fails to execute complex workflows because we deploy it in isolated silos. Retrofitting AI assistants into human applications creates context pollution. Dropping a language model into a corporate chat channel forces it to navigate a sea of irrelevant, unstructured noise. This environment relies on opaque autonomy. Linear chat lacks structural visibility, meaning autonomous decisions are made in an environment that enterprises can neither audit nor trust. The Topic Ledger Framework, or TLF, is a mathematical and architectural operating system designed specifically to bridge this orchestration gap. Executing autonomous workflows at scale requires abandoning chat-based interfaces for an architecture where human and machine cognition are unified. The topic ledger theory is built on the axiom that context precedes content. Meaning can only exist within strictly bounded parameters. Within the TLF, the core unit of work is the topic, a multidimensional context container that functions as an active vector store. In this system, human workers and AI agents are mathematically treated as identical nodes. They act as subtopics interacting within the parent topic's container. Each topic operates on a thermodynamic lifecycle. It functions as an active processor while domain events remain unresolved, triggers requiring a decision. Once the work is done, the topic freezes into a static, archived blueprint of the process. Treating humans and digital agents as identical nodes within a mathematically bounded container eliminates the structural barriers that cause hallucination. This is how the enterprise moves from individual creation to systemic orchestration. We can see this in action during a credit risk analysis initialized as a new topic. The system begins an auto-indexing process. Every interaction, document, and decision is chunked and embedded in real time into a vector store specific to this topic. The matrix acts as a shield. This enforces semantic containment, preventing an agent from accessing irrelevant data points from unrelated company projects. This enables filtered RAG. By combining semantic vector searches with strict metadata filters, the system limits the AI's context to nodes authored by the compliance agent or labeled as urgent. Filtered RAG solves the cold start problem. It guarantees that AI agents reason exclusively with high-signal context from the moment a workflow begins. However, reasoning is only productive if the agent can manipulate live enterprise systems. In the TLF, AI agents bring their own personalized workspaces into the topic, owning GitHub, ERP, and CRM accounts just like a human employee. This is facilitated by the Model Context Protocol, or MCP. It is an open standard that allows agents to bridge the gap between their isolated neural networks and dynamic enterprise databases. MCP uses a client-server architecture to separate the AI's cognitive intent from the mechanical execution. The server gate validates permissions before any task is performed within the silo. This standardizes the integration process, empowering digital agents to operate as autonomous employees without compromising the security of the underlying data. These agents are driven by domain events, actions triggered by specific time windows or specific data thresholds and human signals. A domain event initiates a collision. This is a dialectical debate where specialized agents and humans intersect to negotiate a specific resolution. The danger in multi-agent systems is agent drift, where one hallucinating model cascades its errors across the entire network. The TLF applies the Shapley value from cooperative game theory to manage this. Each agent pushes against a central decision point, while their weight values continuously recalibrate based on their specific input. The Shapley value calculates the exact marginal causal contribution of each actor. This ensures that the final consensus block is a product of semantic accuracy rather than computational dominance. For high-risk decisions, the system triggers a workflow intervention. Humans act as asynchronous circuit breakers, using label triggers to review and approve the consensus outcome. By framing work as mathematical collisions, the TLF transforms probabilistic AI guesses into rigorously validated consensus. Every outcome from these collisions is permanently recorded. This is the immutable ledger. While it appears as an asynchronous feed, it functions as a cryptographically linked history of the entire enterprise. The ledger stores more than just the final decision. It captures the complete chain of thought for every agent involved in the collision. This provides a complete audit trail. An autonomous decision traces back to the exact page-level data chunks in the vector store that influence the AI. Absolute state persistence provides the visibility required to move past the black box nature of current AI models. Because the ledger is a perfect record of the past, we can use it to model the future. The system applies assembly theory to the ledger's history. It measures the structural complexity of past decisions to define an assembly index, the minimal steps required to reach a valid consensus. Then, using quantum retrodiction, the system scans these historical chains. By treating the ledger as a traceable timeline, it can infer the specific origins of past errors or bad blocks. By identifying the causal patterns of both success and failure, the system can probabilistically simulate the outcome of a new domain event before spending any computational tokens. If a simulation predicts a logical paradox or a compliance risk, the system halts the process. It can then inject additional data or flag a human for intervention before the error ever occurs. This architecture moves the enterprise from reactive correction to preemptive workflow optimization. In its initial state, before any interactions occur, a new project is just a cloud of chaotic semantic noise. But as interactions cross a specific mathematical threshold and all-or-nothing phase transition occurs, the noise solidifies into a perfect machine-readable ontology. The topic ledger framework is the operating system for the hybrid workforce. It is the end of chat and the dawn of the agentic enterprise.